Unit 7.6, sorting algorithms. We have three: bubble sort, insertion sort, and selection sort. What I'm going to do is I'm going to walk through how they work, because it's just some nested loops like we saw before. Remember that chart that we saw where the n squared algorithms, the quadratic ones? That's a loop inside of a loop. We'll see that. First thing here is there's a swap. These all utilize the swap method here to change the position of the value in A and B, swap them. So for example, we have an array with some data, and we're going to swap the guy at A with the guy at B, and this is the little code to do it. Take the guy at A, save him as temp, take the guy at B, put in at A, and then put the guy at temp at B, accomplishing the swap. We have a print here, just to print to make sure that the actual sorting occurred and the algorithm works. I'm not going to actually run these algorithms. Instead, what I'm going to do is I'm going to do a visual representation and walk through how they work. So let's do that first, the walkthrough, and then we'll see the visual after. This is the place where the visual representation is, and I'll actually look at that after walking through this. So here's the nested. I'm not going to work through these in depth. I'm just going to look through them in a short way. So the first two, these two are nested, and this is a bubble sort. So what it does, it's called the swap if the guy who is at the position in the first spot in J and the guy at J plus 1, we're going to compare those two. Okay, we're using compare to because we're using the integer object, and compare to is the way to go. If it compares the guy in C with the guy in C1, if the guy in C is bigger, he needs to be swapped. That makes sense because he needs to be more right? We're sorting these things in ascending order, so the bigger one needs to be to the right, and we're going to keep swapping. So the idea here is to swap. If that condition is true, we swap, and so the guarantee here is when this is finished, the largest guy is going to be at the top, and that's where it got its name from. Bubble it up to the top. Okay. Next one is insertion. Think of playing cards. Think of playing cards. You get a hand of cards, you take the card and you put it in the right spot. So unlike the bubble sort where it's bubbling something at the top, it's not. It's getting something to compare, compares it, and figure out where to put it. And once it figures out where to put it, it recalls the swap, because let's say the guy needs to go in position 2 and he needs to be swapped with the guy in position 8. That swap's going to take place, and we're going to keep doing that, putting things in the right spot. It's almost like picking up the card and sticking it in the right spot until this thing is sorted. I did this sorting insertion two ways. The reason why I did that is because I have the array list way of doing it, and the one above is an array. So this guy here could actually put things in the spot, right? Because the array needs to swap, but this does not need to swap. This could literally put it in that spot because the array list grows and shrinks. Now realize I can't use a for each loop because I'm changing the list, so therefore I can't do that because it would have that concurrent error, right? That changing list and still using a for each loop. I have a helper here, so my suggestion is to go ahead and take down the helper. You can pause the video here, and you could also pause the video right here and take down this array list insertion sort. Okay, now I have the insertion part with a while loop, so to find where to put the thing, so we gotta also keep that in mind. So we have a triple loop there. Now when we come down here, the last one is selection sort, and this selection sort we're going to see an animation as well for all of these three. We're going to see them. So this one here is look for the largest one. When you find it, swap, and then look for the second largest and swap, and third largest, and so on. So select. So let's recap. Bubble, swap, 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 swap. Keep swapping till you bubble them up. Insertion, pick up the one and put them in the right spot. Selection, scan the entire thing. Look for the largest one and put it at the end. Scan it again. Look for the second largest one. Put it in. And we're going to keep doing that until it's over. And so what we're going to do now is take a look at how these things look visually. So visually, we're going to take a look. First, the bubble sort. Okay. So the bubble sort, I'm going to go ahead and restart it. The bubble sort looks, you can see how these things are all randomly placed. The height also tells you that is a different value. So 44 much bigger than 3. So I'm going to go ahead and go. And it's going to start running. See, it's bubbling right now, taking things, comparing, and moving them up. You can see every time it hits that condition where the things need to be, the bigger one needs to be placed to the right, it swaps. See, no swap here, but a swap there. First run, 50 suggests that this is the first time through. We got the largest one at the thing. Now we're doing the second going through in the inner loop, and we're going to see that the 48. So you see, right now, let's try and slow this down a little bit so we could see. So this 38, no swapping here, but it's going to swap here because 4 is too small. It's going to swap the 19 and no swapping here and no swapping here. So now we guarantee we got the third largest one. We're going to start over again. And this is in order, so no swap. This is in order, no swap. This is in order. This is not in order, swap. This is not in order, swap. And it's going to keep doing that until we bubble the next one to the top. Now we're going to go to the insertion sort. So let's go ahead and restart this. So this is on the stepwise process here. We just got to keep clicking on the step to see what happens. So here's how this looks, okay? This 9 and 11 look like they're in order. So let's go ahead and step C. So we have no problem there. The problem comes in when we come up on this 3. Remember, this is a nested loop, so we're walking, going through from left to right. We have a problem here. This is now out of order. Once we are out of order, it's time to insert. So this 3 needs to be placed in front of these 2. Just like the hand, you know, your hand, your cards, you pick out the 3 and you put it in front. All right, so 3, 9, 11, 20 is in order at this point, so we don't have a problem. The problem comes when we go to the next guy. He's out of order, so he needs to be placed in between the 11 and 20. Next step, boom, there he is. Then we get the 8. 8 needs to be placed in between the 3 and the 9. Next step, and there it goes. 19, definitely out of order, need to be placed in between these 2. And it's going to keep doing that until this whole thing is sorted. Okay? So you could see how the insertion is sorting. This is one of those algorithms that is very good for partially sorted things. If you have something that's almost sorted, I have a few more things to add, this will be one of the fastest. Even though it's an n-squared algorithm, it gets a lot more speed when the stuff is almost sorted. Now I'm going to go to the selection sort. Now visualizing it here, this is the array, same bars, and we're going to step through. If I hit the step, it gives us some information here, but what we're going to do is just pay attention to the visualization here. So highlights that, it's looking for the largest one, found one that's larger. I'm going to click, keep hitting, you find one that's larger, keeps looking, seems like he found the largest one. So what does it do? Swap it. See, largest one, after when going through the entire list, it found 947 to be the largest. Then whoever was at the end, it got swapped. Now we're going to run it again. So we're going back to the outer loop, about to go again and run. So we're looking for the second largest one now. And you're going to keep looking. Found the second largest one at 684 so far. Keep clicking on this. Second largest one is found. What's going to happen? Swap them. See? Selection sort. Select the largest. Whoever is at the end, swap it. Select the second largest. Whoever at the second largest spot, swap it. Select the third largest one, which would be this. Swap it. And so let's run that and see that. So I'm not going to run this code to show you that they actually do sort, because these are very well-known algorithms, and you could literally pause the video and just grab that code and check them out yourself. So you can see right now, we found that this is the third largest one, and we should be swapping it with him. And this is going to keep happening until selection sort fully sorts this. Just like all the others, these algorithms run until the end. So basically, a quick recap, we have the selection sort. We just saw that. Select, put at the end, keep swapping until it's sorted. You have the insertion sort. Think playing cards. Think of taking up something and putting it in the right spot. This is the insertion sort. Very good for partially sorted stuff. Then we had finally the bubble sort, which means keep swapping forever and ever until we bubble the first one up, and then do it again to bubble the second one up. Like I said, the print is here to test it out. We need the swap as well. So you go ahead and make sure you pause the video. I'm going to run back down, swap and print. You can pause here. You can pause and get the bubble sort. as well. You can now pause it and get the insertion sort, and I have the insertion sort again, this time with an array list as opposed to an array. You can pause it and make sure you get this piece right here, and you can pause it and get the helper for the insertion sort with the array list right here. And last but not least, we can pause it and take down the selection sort. Make sure you grab them and also test them out. Make sure that they're sorting the array. Now, these are non-static. So if you're going to test them out, you have to create the object. Okay, and I did that on purpose so we could go back and forth between the non-static method and a static method. Sorting, big part in computer programming, and it is all covered in Unit 7.6. All n-squared algorithm, bubble sort, insertion sort, and selection sort. This brings us to the end of 7.6.